Welcome back to Chapter 5 Study Guide for Algebra 2 Trig Honors. We are going to start on number 3. So number 3 asks us to find the inverse of this function. So remember, the inverse is just swapping the x and y values, then solving for y. So I'm just going to first start by swapping my x and y values. Now remember, this f of x represents my y. So I am going to have x equals 2y plus 3 over 5y minus 2. Okay, now I will forewarn you that this problem, the answer, is weird at the end, so we'll get to that at the end. Okay, so our whole goal is to solve for y. So that means we need to get y by itself. Whenever I see a problem like this and I have a fraction, the first thing I think to do is to get rid of the fraction in the denominator. So I'm going to multiply both sides of my equation by 5y minus 2. Now that's going to get rid of the 5y minus 2 in the denominator there. And then I'm going to distribute my x here. So remember, this gets the x and that gets the x. So 5y times x is just 5yx and minus 2x equals 2y plus 3. Okay, now what we want to do is, again, we're trying to get y by itself here. So what I want to do is I want to get all of my terms that have a y on one side of the equation. So I'm going to subtract 2y from both sides. And that 2y can't combine with anything. It can't combine with this one because it has an x, and it cannot combine with this one because it only has an x. So we have 5yx minus 2y minus 2x equals 3. Okay, now this one doesn't have a y, so I want to move it to the other side of the equation. So I'm going to add 2x to both sides of my equation. I'm going to move my work up here. So now I have 5yx minus 2y equals 2x plus 3. Again, our goal is to get y all by itself. So what we need to do is we're going to factor out y from each of my terms. So 5yx and 2y, they have a GCF of y. So I'm going to factor that out. So what's left now is the 5 and the x, and then the 2. Okay, again, our goal is to get y by itself. So this is being multiplied, so the way that we get rid of it is by division. So my inverse is here. My answer, 2x plus 3 over 5x minus 2. Now, I said in the beginning this problem ends up to be weird. It is weird because the inverse is the same as the original function. You did it right. I know some of you probably did this and were like, what the heck happened? But you did it right. It just so happened that I picked numbers that worked out to be like this. So my inverse is 2x plus 3 over 5x minus 2. Now, on a test, you probably wouldn't have one that would work out like this because it's a little weird. Okay, so let's look at the domain and range for each one. Now, with this one, because they're the same, the domain for each of these is going to be the same. However, I'm going to kind of still explain it through how we get to everything. Okay, so the first one says find the domain of f of x. So that's our original function. So the domain of f of x. Now remember, it's a rational expression, right? The variable is in the denominator. So if it's a rational expression, we need to find the excluded values. So we set our denominator, which is 5x minus 2. And remember, it cannot be equal to 0. So we'd add 2 to both sides, divide by 5, and x cannot be equal to 2/5. So that gives me my domain for f of x. So it would be, for all x values, x can't be equal to 2/5. Now, our domain of our inverse, now, of course, our domain, our inverse is the same as our original function. So, it's going to be the same thing, but let's look at it still. So it's a rational expression, which means we're finding our excluded values. So we set our denominator equal to 0 to find which values x cannot be. So we add 2, divide by 5, x cannot be equal to 2/5, like we got before. Okay, so now comes to talking about our range. So remember, the range, well, let's kind of back up even further. The inverse is about swapping the x and y values. The domain is my x values. The range is my y values. Domain is x, range is y. So the domain of my original function is going to be the range of my inverse because it's just swapping the x and the y values. So this is the same for here. But remember, range is talking about y values, so we rewrite it as, for all y values, y can't be equal to 2/5. Now it works the same backwards, right? So the domain, my x values, are the same as my y values of the original function. So it's going to be the same up here, except for the fact that the range is dealing with the y, so y cannot be equal to 2/5. And that does it for number 3. We are going to move on to number 4, which is everybody's favorite types of problems, graphing. Okay, so when I look at number 4, I have to decide, is it an exponential or is it a logarithmic function? How do we know if it's an exponential? Well, the variable will be in the exponent. How do I know if it's a logarithmic? Well, it will either say log or ln. Those are your giveaways there. Okay, so we have an exponential equation. My parent function here is 2 to the x power. So remember, for exponential equations, and we can think about this, for exponential equations, if I plug in -1, well, 2 to the -1 gets me 1/2. If I plug in 0, 2 to the 0 gets me 1. If I plug in 1, 2 to the first power gets me 2. So that is my table for my parent function. And then, and that's going to be follow the same routine for all exponentials. Your x values are going to be -1, 0, 1, and your y values are going to be 1 over a, 1, and a, where a is whatever the base is here. Now, you can use logic here, right? You could just plug it in, and we'll talk about the difference with an ln or log. Okay, so now let's apply our transformations. So we have 2 transformations here. So my first one is the +2. So the +2 is within the exponent because it's 2 to the x plus 2 power. And so it's within the function, so that means it's going to be a change to the x values. So to all of our x values, remember when it's a change to the x values, we do the opposite operation. So if it's adding 2 here, we're going to subtract 2 to all of our values. And then the -4 is our second transformation. Now that is not within the exponent, so it's outside of the parent function. And so to all of our y values, we are going to subtract 4. Okay, so our original y values, or I'm sorry, our original x values, we subtract 2. And our original y values, we subtract 4. Okay, so our final table, we get -1 minus 2, -3, -2, -1. 0.5 minus 4 is -3.5. Sorry, my 3 got a little weird there. 1 minus 4, -3. 2 minus 4 is -2. Okay, so we can start by graphing that. So -3 is at -3.5. -2 is at -3. And -1 is at -2. Okay, now remember, there were no reflections here. There's just a shift up and down and left and right. So we can look at our hand. That hand looks really red. And look and see, okay, this is my logarithmic. This is my exponential. E comes before L in the alphabet. E is on top of L. And so exponential looks like this. And so I'm going to mimic my graph just like the curve on my hand. And go from there. Okay, so now comes the domain, range, and asymptotes. So the domain here is, let's look. Our domain is our x values. So from left to right is how we look at domain. And so from left to right, it goes from arrow to arrow, and it's continually going up and out. And so our domain for any exponential equation is always going to be all real numbers. Now our range is a little different. Our range for a parent function is typically 0 to infinity for any exponential. But because our y values move down by 4, that means our range is also going to move down by 4. So instead of being from 0 to infinity, it's now going to be from -4 to infinity. And then our asymptotes, now we have a horizontal asymptote, which means our equation is going to be y, and y is equal to -4. Now, if you want to draw that in, by all means do. So we have a horizontal asymptote right there. And that is your answer and work and all of that for number 4. So let's do number 5 in comparison. Number 5 says to graph the function f of x is equal to 2 minus ln x plus 1. Now, so in comparison to number 4, which we just did, this is a logarithmic function because of that ln. What I'm going to do first is just to help my brain see all these transformations, I'm going to rewrite this because this 2 on the outside may be a little deceiving. So this is the same as if I were to write negative ln of x plus 1 plus 2. Okay, so first off, I'm going to write my parent function. My parent function is ln of x. If it helps you to, instead of writing ln, remember, you can write log base e of x if that helps you. They're the same thing. I would be totally fine if that helps you and you write that. I don't mind. Okay, so let's start with our table. Now, remember, ln, or any logarithmic function, is the inverse of an exponential. So that's why when we look at our table of an exponential, our x values are -1, 0, and 1. And on our logarithmic, our y values are going to be -1, 0, and 1. Because it's the inverse, we swap our x and our y values. And then ln is, for -1, it's swapped. Where this was 1 over a, it's going to be the same thing, where a is my base here, which is e. So it would be 1 over e, 1, and e. Okay, so tackling the table, I'm sure, is like half of the battle. Now on to our transformations. We have 3 different transformations here. So our first transformation is going to be this +1. So that +1 is built into the ln. So it's ln of x plus 1. And so that's within the function, so it's a change to our x value, which means opposite operation. So I'm going to subtract 1 from all of our x values. Now our 2 other transformations are this +2 and this negative on the outside. Both of these are outside of the ln. So they're both affecting the y values. So it would be negative y +2. Okay, so remember 1 over e. Now you will have your calculator. So if you need that friendly reminder of where e is and all that stuff, here's our calculator. Zoom out a little. Try not to get that glare there. Okay, so if we look at our calculator, it would be 1 divided by, and e is above the division sign, so second divide, and it's 0.37. Okay, I'm going to zoom back in here. Okay, so 0.37, 1, and 2.72, and to all of those we're subtracting 1. And then to all of our y values, which is -1, 0, and 1. We're first multiplying it by -1 and then adding 2. Okay, so our final table, 0.37 minus 1 is just -0.63. 1 minus 1 is 0. And 2.72 minus 1 is 1.72. Okay, so then -1 times -1 is +1 plus 2 is 3, 2, and 1. Okay, so now that I have my final table, I can start graphing my point. I have -0.63 at 3, 0, 2, and 1.72 should be over here at about 1. Okay, so remember our logarithmic equation. Now first, I will preface it by saying this negative on the outside. Now it was a change to the y's. But remember that negative means it's a reflection. And so what that means is it's a reflection. If it was a change to the y, it's a reflection over the x-axis, which our x-axis is here. So if we're looking at our original logarithmic equation, which on my hand is this one, it's flipped up now. So it's reversed, right? It's reflected over the x-axis, which is essentially like, oh, I can't flip my hand like that. So we'll just graph it. So now that we have our graph, and I guess I got a little too crazy with my curve here because we do have a vertical asymptote on this one. And you'll see what I mean in a second of why I got a little too curvy on that one. But let's start with looking at our domain and range. So as we did our problem up here, our exponential number 4, the domain is always all real numbers, and the range of any exponential is 0 to infinity. Now, there's like a whole band walking down my street. That is interesting. Anyways, side note. Okay, so with this, remember, your exponential is the inverse of a logarithmic. So our x and y values are flipped. So the domain of an exponential is going to be the range of a logarithmic. So the range of any logarithmic is always all real numbers. And then the domain is the range. So the parent function always starts from 0 to infinity. So, 0 to infinity is my parent function. But all of my x values were subtracted by 1. So 0 minus 1, negative 1 to infinity. Now, we can always look at our graph to make sure that that makes sense. So if we're looking negative 1, and again, my graph got really curvy, I'm going to cross out what it shouldn't have done, and it should have been like that, actually. So it's negative 1 to infinity, and my range is negative infinity to infinity, because this continues to go down. Now, our asymptote, remember, the exponential is a horizontal, so our logarithmic is going to be a vertical. And so x is equal to, and it always is the same as the domain, negative 1. Now remember what I told you about the domain of logarithmic equations. You can set what's inside that x plus 1, and you can say, okay, x plus 1 is greater than 0. Subtract 1 from both sides, and x has to be greater than negative 1. And that will always work for your domain. Now, if we wanted to draw in our asymptote, and I would have totally marked you down if you would have kept my graph. And the reason I would have is because my vertical asymptote is at negative 1. So I would expect you, if you got a little too curvy, to have crossed it out or erased it and drawn a better graph representing that it cannot go past that negative 1. So apologies for getting a little crazy with the graph there. Now the band is playing outside. I think they're here for me. No, they're not. I'm totally kidding. Okay, well, that ends it for number 5 and ends it for this video. So we're going to continue the next problems on the next couple of videos. So see you then.